Viewers, in today's class we are looking at term likely question, and if as a student you come across this kind of jam chemistry question, how can you solve it? Come closer, let's show you the secrets behind how you can easily deduce your answer as far as any topic is given in jam chemistry. Come closer for this question. It said the electronic configuration of a element is this. The number of unpaired electrons present in the element is option A, we have 1, option B, we have 2, option C, we have 3, while option D, we have 0. As far as electronic configuration is concerned, the first thing you need to know is that the element given to you is picked to be 1s2, 2s2, 2p2. This element is carbon. We'll call it carbon atom with atomic number what? 6. Now, one thing you need to know is that how can you deduce your unpaired electrons? For the fact that you are given the electronic configuration of the element you are asked to look for the unpaired there, the first thing you need to know is that you should be able to identify the element, which is the first thing we just did on the what? On the whiteboard now. Carbon atoms is that electronic configuration for this. So now, the next thing you need to know is that what is that rules that governs how you can easily deduce the unpaired electron? According to Ohm's rule, electron must be singly filled before pairing occur. I repeat, according to Ohm's rule, electron must be singly filled before pairing occur. So let's take a look at, we have this stand for our s orbital. This, we have our p orbital, and don't forget we have px, py, and what? Pz. So I will only make use of these two degenerate orbital since we are only given the s and the p orbital. Are you with me now? So guys, element carbon with 6, that is the atomic number of carbon, and we have this. So the first thing you have here, which is 1s2, we take the position of what we call the helium core under hybridization. If you are just coming across my video, check my YouTube catalog. I've dropped a full video on how you can understand the concept of hybridization. So guys, 1s2 is helium core, while the 2x will picture this. We have, and how many electrons we have here? 1, 2. The next one is what? This, the p orbital. How many do we have here? Mind you, you have px, we have py, and we have what? Pz. And this degenerate orbital can contain 6 electrons. So guys, if I have this, what I just did here is I obey Ohm's rule that electron must be singly filled before pairing occur. That is, if I have this now, for the 2p we have here, I can have this as well. So let's singly filled like this now. This does not obey Ohm's rule. Why this obey Ohm's rule? Because Ohm's rule states that electron must be singly filled before pairing occur. So guys, may looking at what you have on the board here, this still picture our 2s2. This is a picture of our what? 2s2. It's still the same thing. So guys, how many unpaired electrons do we have here? What you have on the board here is called the ground state. I repeat, what you have here is called the ground state, unexcited. But If I should pick one of these electron here and singly feed it to that place, it is called the excited state. That is not where we are going to. We are only asked to identify the number of unpaired electron present in the electronic configuration given. So guys, now we have px, py, and what, pz. So guys, this is paired already because we have two electrons there. But here it is singly filled according to Ohm's rule. So the unpaired here is 2. We have 1 and we have what? 2. I repeat, this one here, this 2s2 here is paired already because we're having two electrons there. But in this degenerate orbital of that p, we're having one for the px, another one for the what? The py. So these two, they are not paired. That is why we have two unpaired electrons for carbon atoms. So guys, option A is not the answer. Why option B, picture, the solution we just show you on the board. So the correct answer is option B. So guys, when we talk about the electronic configuration, you need to understand the concept of how we can easily deduce the element at which you are given the electronic configuration of. Without you knowing the element given to you, you can picture or deduce the answer. So guys, this is how you can easily deduce any question as far as you are asked to bring out the unpaired electron of any given elements you come across in your examination. So guys, don't forget to subscribe to my channel, like, share. If you have any question, do well to drop it in the comment box.